So we're going to continue working with section 2.4 a little bit, talking about the graphs of sines and cosine functions. And in particular, let's pick it up with problem number 66, which asks us to graph this thing. Now, there's a few things that we're starting to get used to in terms of the graph of a sine and cosine function. In particular, what is this 2 going to do to the graph of a sine function? If I put a 2 out in front of a sine, what's it going to do? Good. It's going to make it go up and down a little bit taller. It's going to go up to 2 and down to negative 2. So let me take a quick look at that using Desmos. Here's the graph of the sine function, y equals sine of x. But if I put a 2 out in front of it, y equals 2 sine of x, then what you can see is that the amplitude has changed. The graph jumps up and down between negative 2 and 2. Now, these values, negative 2 to 2, those are the y values that the graph passes through. And those y values are called the range. So what you've done is you've changed the range of the function from negative 1 to 1 to negative 2 to 2. So let me write that down as part of our answer here. So it's going to be negative 2 to 2 is the range. And that matches the coefficient here, or it's at least related to that coefficient. Now the coefficient here wasn't just 2, it was really negative 2. So what's a negative going to do when I add it to this graph? Yeah, it's going to flip it. So if I do y equals negative 2 sine of x, then it's going to flip it. This is getting a little too busy, so let me get rid of the other one. But now we're doing two things. You're flipping it and you're stretching it. So the amplitude is still 2. When you're looking at the amplitude of a graph, you don't look at its sign. You're just going to take the absolute value of that. So the amplitude is 2. The range is still negative 2 to 2. By the way, the range is the y values. What do you call the x values of the graph? Domain. What's the domain for the sine function here? Yeah, everything. Sine is defined for everything. Now that's not always going to be the case with your trigonometric functions. But in this case, the domain is everything. So from negative infinity to infinity is the domain. Let me just click over here, write that down for you. Now, that's always true for the sine and for the cosine. Yeah. So those are the only two trig functions that are defined everywhere. Other functions, as we'll see starting in section 2.5, are going to have issues at certain problems or certain points. But sine and cosine are very, very friendly functions.
Do you want us to write it out as negative infinity to positive infinity, or can we do that R?
Script R, boy, I like it when people remember that script R. That's cool. Yeah, I like that. So yeah, feel free to do that, and I will feel free to give out extra credit points as needed. So, well, only where yeah, I got to qualify that because somebody put literally the script R next to every single problem on their test. And was somehow incensed when I didn't give extra credit for every single one of them. Now let's think. There's one last thing that we're going to adjust, and that is we've got a number out in front of our x. That number, that coefficient, divides the period. Now, let's go back here and think about the sine graph here. And let me just ditch that for a second. What's the period of the sine function? How far does this thing go before it repeats itself? How far does the graph travel before the sine graph starts to repeat?
2 pi.
2 pi. So the period of the sine graph is 2 pi. So this number is always going to divide the period. So when you're graphing y equals a sine of bx, b is going to divide the period. So the period of this graph is 2 pi over b. So in the case of problem number 66, let's figure out what the period of this is going to be. how often is this graph going to start to repeat itself? Or how far, starting say at the origin, do you have to move to the right or to the left before the graph repeats itself? So let's find out. Period is going to be 2 pi divided by pi over 2. Let's think of that as 2 pi over 1 divided by pi over 2. And I just throw in the over 1 so that I've got a pair of fractions. And when you divide fractions, what's the operation? What do you do here? Good. So 2 pi over 1 times 2 over pi. You're going to get some nice cancellation here. Units of pi cancels itself out. Do the 2's cancel out? No. So you should see a period of 4. That is, you should be able to start out at the origin and move 4 units to the right, and the graph should be starting to repeat itself. So let's take a look at that on Desmos. So let me just modify this function a little bit. We want pi x over, oops, I don't want that over. So let's highlight this, divided by 2. Something doesn't look right. Oh, yeah, it'd help if I turn it on. Thank you. I was looking at that and going, wait a minute, that's not doing what it's predicted to be. So if you look here at the x-intercepts, you can see that this graph repeats itself every 4 units, right? Starting out at 0, 0, you move over to 4, 0, you're at the same point in the graph. If you start out here at 2, 0, the graph is going up, and then comes down, then comes back up again another 4 units later. So the period of this graph is 4. And that coefficient here helps you determine the period. Has the domain of this graph changed as I change the coefficient there? No. The domain is still the same. It's still all real numbers. The range is still the same. It's still from -2 to 2. But the period has changed. We changed the period by multiplying by pi over 2 inside the argument of the sine. Let's try a different one, unless there's some questions or thoughts on that one. Let's move up to problem number 72. This time our function is y equals -1/2 times the sine of 3 over 2 times x minus 1. Now that minus 1 is kind of interesting. We'll take care of that last. First things first, let's worry about this -1/2 here. What's that -1/2 going to do? There's 2 things that are going to happen. It's going to change the amplitude and flip the graph. So the graph's going to get flipped. What's the new amplitude of the graph? Good. It's the absolute value of -1/2, or better yet, just 1/2. So that's your new amplitude. If you were just looking at that, just this much, what would be the range of your new function? Yeah, -1/2 to 1/2. The regular sine function goes between -1 and 1. Our new function here would have a range between -1/2 and 1/2. That's before we take care of this -1. So what do you think the -1 here is going to do to the graph? It's going to shift it down by 1 unit. So let's take a look at these things a piece at a time. Do you want to spend a moment looking at it on the graphing calculator? Because you're not going to have Desmos available to you on an exam. You are going to have it on your graphing calculator. If you need to borrow one, come on up. You know the drill. No, just the driver's. I don't want your whole wallet.
There's no money in it.
Well, then I definitely don't want your whole wallet. Thank you. All right. Thank you. Thank you. Uh-huh. Okay. So let's plug in our function. Let's click over to the screen. Hit the y equals key. Let's enter in. Now it's convenient, instead of trying to deal with the minus 1/2 and a fraction or something like that, just enter minus 0.5. All right, let's keep it simple. Minus 0.5 sine of 3x, or excuse me, 3/2 x. Well, again, you could use a decimal. There's nothing wrong with that. You just do 1.5x. I mean, there's nothing wrong with doing the equivalent thing, 3x divided by 2. You know, it's just whatever you find convenient. So, in any case, minus 0.5 sine 1.5x minus 1. Clear out anything else. And now we need to figure out where we want to graph it. So let's set up our window. So hit the window key on the x-axis. Well, let's go from, say, well, negative 2 pi to 2 pi. So type in a negative. Use the opposite key on the bottom row of the calculator. Don't use the subtraction key to enter in negative numbers. Negative 2. Where's pi at? Where can you find pi in your calculator? It's programmed in. Yeah, right above the little up arrow here. So you hit the second key, then the up arrow. You'll see pi for a minute until you press enter. And then you're going to get the decimal value there. So we've got minus 2 pi. And hopefully you see the rest of this. That's positive 2 pi. On the x-axis, we're going to see a tick mark every 1 unit. That's what that x scale is. Now on the y-axis, if I graph this between 3 and 7 on the y-axis, which is my settings, I'm not going to see anything, am I? Because we know that my graph is going to get shrunk between negative 1/2 and positive 1/2, and then further shifted down by 1 unit. So on the y-axis, on the low side, let's go down to negative 2, and on the high side, let's go up to 1. Now, that's going to be more than we need, but it should satisfy our needs. Make sure your calculus or your calculator is in radians, not degrees. If it's in degrees, hit the mode key, and then go down to this line and change it. So put the cursor on radians, press enter. When your setup is correct, press the graph key. Yay. There's our graph. Now on the y-axis, I put tick marks at every unit. So you can kind of see roughly what's going on here. What's the maximum that those tick marks get to? What's the biggest that they get to? Along the y direction. What's the tallest tick mark, or what's the tallest value of y you're going to find anywhere in this curve? Negative 1/2. Good. You can hit the trace key and kind of play around, trace around, and the best you're going to do is a negative 1/2. What's There's your window again. Sure. Let's go back to the graph. So what's the lowest that it's going to get to? One thing you can do to calculate that is you know that the range of this function is going to be between negative 1/2 and 1/2. But then this is going to be a shift down by 1. Shift down by 1. So if I subtract 1 from all this, if you subtract 1 from the range, negative 1/2 minus 1 is negative 3/2. 1/2 minus 1 is negative 1/2. So that's the shifted range. This matches the graph that you see. No, that's just a vertical translation. Yeah, period shift is going to look a little bit different. Actually, we'll do a phase shift is what we'll be doing. Phase shift. Okay, so let's think here. One other thing that I'd like to know about my graph is what you just asked. What's the period? So to figure that out, I can look inside the function. I've got 3/2 x. How am I going to figure out the period now? All right, so 2 pi divided by 3/2. So again, you get to simplify a fraction. 2 pi over 1 times, let's just go right to the chase, the reciprocal, 2/3, is going to be 4 pi over 3. It's not going to be terribly clear looking at your graph that it repeats itself every 4 pi over 3 units. But you can probably play around and check it. Are you okay with the calculation here, though? Let's see if we can't check it. So accordingly, if we start out at 0, we're at this point. If you hit the trace key, let's see, let me type in a 0. So trace it at 0, we're at negative 1. Let's also trace it at 4 pi over 3. Now when you're using the trace key, if you want to enter in a value for the function to move to that point, you got to type something before it's going to open up the line down here at the bottom. As soon as I type a 4, watch what happens on the bottom row. It's going to open up that row. 4 pi divided by 3. Now when I was at 0, I was at a height of negative 1. Let's see where I'm at 4 pi over 3. Bingo. I moved over and I'm again at a height of negative 1. So 4 pi over 3 is your period of your new graph.
So if that was like negative 1/2, that would be wrong.
Correct. Yeah. Then you would have made a mistake in your calculation about the period somehow. What's the domain of this function? Yeah, all real numbers again. Okay. The domain is your x values. And sine and cosine are defined nice and neatly for all your x values. Okay, let's reverse engineer a couple. So a couple more problems to finish out the section. Problems 60 and 62. So problem 60 asks us for a sine function with an amplitude of 2 and a period of 4 pi. All right, so we need to write an equation with this given characteristics. So our equation is going to have this form. Y equals a sine of b times x. We need to figure out what a and b are. All right? Yeah, there's really a couple choices for a, right? A could be 2. What else could a equal? Yeah, a could equal negative 2. It would still have the same amplitude if it was 2 or negative 2. No, most people put a positive. I'll probably put a positive one on my answer key, but if you wrote a negative one, nothing wrong with it. I can't complain about it. because negative 2 would still have an amplitude of positive 2. The next thing to figure out is what's b. B has to be figured out in such a way that the period of this graph is 4 pi. So let's go back to this idea. The period of a function like this is a nice little quotient. What's the period of that function? 2 pi over b. Well, we know part of this, right? We know the period is 4 pi. And that's equal to 2 pi over b.